significantly affects the least squares regression line, slope and or y-intercept, or the value of the correlation coefficient. By definition, I think, let's say, or coefficient of determination, because I think that's what they want you to look for in the homework, is they just want you to look at this one. I'll double check, I'll pull it up at the end and we'll go through the last problem from the homework, because this one's going to be a little tricky, how they want you to do that, but we'll look at that one at the end. So I think this is the one you want to double check for your homework. Okay, so then they do an example here, kind of straightforward, how you can tell when they, how it affects it. So we've got most of the states are going to be over here in blue, 48 of them, and we're looking at how much land they actually have and how much of that land is used for farmland. So those are the two things that they're comparing. So you can see this blue line right here is going to be the least squares regression line for all of the little blue dots, all of our normal states. So there's a pretty good positive linear correlation between the two. So if you throw in Texas, this one right here, Texas, that's got quite a bit of land area, but it also has quite a bit of farmland. So if you throw in Texas into the mix, if you've got them all in your L1 and your L2, all 48 of them, and then you add a 49th line where you add in Texas. It alters it a little bit, so you got this red dashed line, and that's what the line becomes. It moves it a little bit, but it's still pretty positive. It hasn't moved it all that much. So that one we'll say is probably not going to be an influential point, because while it does change the line, it really doesn't change it all that much. But if you look at Alaska all the way down here in green, it's got a bunch of land area, but most of that can't be used, so they don't have a whole lot of farmland. So Alaska is definitely going to be an influential point, because when you throw Alaska into your L1 and your L2, put it down at the bottom, your line becomes this. So it's still kind of positive, but it's really not as steep as the other one. So this green line right here is heavily affected by just this one point. And so this point is going to be considered an influential observation, because it does draw that line way far down. So it's completely different than what you see up here with the red and the blue. So including Texas moves the line somewhat. The green line causes a big shift. We don't say here, but Alaska is an influential. So that's just, it doesn't have the numbers because it would take too long for us to actually go through and calculate all of that. So they're just giving a graphical representation where they actually did the work to kind of show you what it looks like. But down here we're looking at our drilling time. So we've got another one here. So they started at a depth of 300 feet, which is a lot deeper than all the other ones were. And then they said it took 12.49 minutes to drill 5 feet, and they ask if it's influential. So they have this graph over here. Here's our least squares regression line in black. For what we did before, we graphed that on our calculator. But now it looks a little different, because our units go further out, because we have to have this 300. So up here, this dot is included, and so it changed it a little bit. So instead of just eyeballing it and trying to figure out if we think it's been changed a lot, we're going to look at our r-squareds instead. So before we found our r-squared for this one, for the drilling data, to be 0.597. So 0.59. Oops, that's supposed to be 7. Sorry. 7. Now if we go through and we recalculate our r-squared, I've already got my stuff in here, so I'm not going to retype it. I'm just going to go through and add these numbers. So x is 300, that's how many feet. And then 12.49, that's how long it took. So I'm going to add those to it, and now I'm going to go through and I'm going to go to stat, calc 4 to get my linear regression, and now my r-squared is going to be 0.753. So it went from 0.597 up to 0.753. So we'll go ahead and say, since there is kind of a difference between those two, that the outlier is an influential point, because it did affect our least squares regression line here, and it also increased our R squared right here. I think this is what they want you to look at when they do the last problem in the homework.